Hi everyone, in this video we're going to look at the characteristics of series and parallel connections in a DC circuit. So the circuit to my left shows two resistors R1 and R2 and R2 connected in series, and the circuit to the right shows R1 and R2 connected in parallel. So what are the main differences? Okay, so let's begin with the series circuit. Notice that beginning from the EMF source, as we go around the series circuit, there is only one conducting path. So the first characteristic of a series circuit is single path. Okay, single conducting path from the positive terminal back to the negative terminal. The second characteristic in terms of the current, which is a consequence of the first, okay, if we have a current I flowing in the circuit, then the current through R1 must be the same as the current through R2, and this is a consequence of the conservation of charge. Charge cannot be created or destroyed, and charge does not pile up in a circuit, so the charge or the current through R1 must equal the current through R2. So any elements connected together in series must have the same current. And one consequence of this is the fact that if one of the elements, the circuit elements, were to be broken, then the circuit will become open or incomplete, which means the remaining elements will not work. So for instance, if R1 and R2 were two light bulbs, if R2 was broken, then R1 would not work, because for R1 to work, it must be part of a complete circuit. Now let's look at the parallel circuit. Again, in terms of the path, conducting path, starting from the positive terminal of the battery, going round in the circuit, at this point we have two options: to go through the upper branch or through the lower branch and then back to the negative terminal. So the first characteristic of a parallel connection is a multiple conducting paths. So I'll just write multiple paths, but that means multiple conducting paths. That means charges in a parallel circuit have the choice of going through one path or the other. And in fact, the current through the circuit is going to split up into two currents depending on the resistance R1 and R2. More current will pass through the branch with less resistance, and then the currents will recombine at this junction according to Kirchhoff's junction rule. The second characteristic is the fact that the potential difference is the same. So same voltage. And let's look at how the two right ends of R1 and R2 are connected. You would see immediately that the right ends of both resistors R1 and R2 are connected to the negative terminal, and the left ends of R1 and R2 are both connected to the positive terminal of the battery. That implies the 2 points represented by these dots have the same potential. Okay, so the potential difference across R1 and across R2 is the same. So this is how to recognize if two elements are connected in parallel. First, there has to be multiple paths for charges to flow, and the potential difference across the elements has to be the same. And a consequence of this is the fact that if one of the elements were broken, then the circuit will still work, because charges flowing from the battery will still have a complete path to go around and come back to the negative terminal. So that's the reason why most household electric elements are connected in parallel, so that if one device is broken, then the rest of the devices will still work.